So today's lesson is about news. Okay, the new chapter is on vectors. Now remember this sitting.
You gotta fix your tag.
What?
You gotta fix the tag in the back of your sweater.
There's a tag, sir? Pick it up.
No, just like put it in. No, you put it in right.
Okay. So this chapter basically is the foundation for. Just want to show the name of the chapter is vectors, but this is foundation for calculus BC Calc 2. Okay, there is calculus 1 and there's calculus 2 and there's calculus 3. So this is the foundation for that calculus 2. Now, question arises. Jasmine, can you read this quickly?
A jet is flying through a wind that is blowing with a speed of 55 miles per hour in the direction north 30 degrees east. The jet has a speed of 765 miles per hour relative to the air, and the pilot has the jet in the direction north 30 degrees west. Find the true speed of the jet and find the direction of the jet.
Okay, suppose can you just, as I said, we are not going to solve, but can you get an idea what's happening where the with respect to, let's see, this is the just think this is the airport. Okay, this is the, okay, got it, that part. And in your notebook you can just take a note just to start like what's happening here. So this is where the jet starts. So where do you think what is the meaning now? What does this N?
Between north and east.
So which one is not
The top.
correct? So we know already, right? We know x-axis, this is the x-axis, this is y-axis, naturally north, west, sorry, yeah, west, and this one is
East.
east and south. Can you quickly write down this and we'll just make a figure, draw the figure, and then we go, okay, let's define what is the vector down here, okay? No, in the notebook, that part comes out. Now, I'm not going to mark anything, just let's see, so which direction should I go, like, and that's the question here. The plane starts, this is the airport, so it says north 30 east, right? So my question is this the one, 30 degrees? Is this how direction it goes? Or you don't agree with me? If you don't agree, which direction it should go?
Yeah, I think it's that direction. But I was thinking it might be in the 60 because it's saying north 30 to east, so I was thinking it would be in the 60.
Oh, yeah. Okay, so you're thinking this is 30, that is 60, and because the north starts first, N, see that north start? Okay, so this is 60.
Yeah.
Anything you want to say, Leslie? Of course, you're not expected to know this, but I just, because actually, you know, when the pilot, when they are flying, they have a certain norms, like, you know, they always have to stick to their kind of thing. Jocelyn, would you like to say something? Do you agree with him? He's saying this is the direction it goes. He's saying this is 30. Well, there is a 30, and you always told us that any angle the right way is begins from the initial side. Remember, when we talk about the anti-clockwise direction, we always draw this way, right? It goes in the, remember that theta which we are talking about? So that's always the theta, right? And I always, if this is the angle, then this is theta. If this is the angle, then this is theta. So always start from the x-axis, okay? But in this example, in the case of a plane flying, they always start from the north side, okay? That's a special, and we don't know why, but that's how the engineering, they say, okay, the north is where they think of, and they call it a bearish. And this angle that we are talking is also, can you write this angle? Bearish. Now what is the meaning of bearish means? Like in the cryptocurrency, is it, oh, the market is bearish? Bloodbath, we say, suddenly cryptocurrency, you know, somewhere it was 60,000. Do you remember the Bitcoins was 60,000? Anybody remembers? It went 60,000. I bought when it was 40, and I got 60, and then it went down in the last 4 months into 18,000. I lost all my money. I said, forget, I took everything. It went, now it has gone to 20 and nothing. Anyway, I'm not doing nothing of cryptocurrency with all those. Put something in, which one? Bitcoins, and I had put also on, what is that? There are so many. Deuterium, you know deuterium?
Yeah.
So I put almost a lot, but then I lost everything. Everything crumbled because of some big giants, finance big. They pull out, they sell that thing, and it goes down, some kind of thing. Anyway, my point what I'm talking now. Okay. So when they give something like this, they think from the north side, okay? So when the plane is flying like this, the pilot makes an angle of, so if this is not, that is this, so 30 degrees will be this side. Can you see now? Make sense? So let's draw that quickly. So this is the angle 30. Let me do this. So the plane is flying like this. Northeast. And what is this one? 30 degrees. Yeah. Wait a minute. Let me see whether I copied that question correct. Because north.
In vectors, it's
Jet. Can somebody tell me where is my mistake? Can somebody tell me where is my mistake here? Is the plane flying this here?
Wait. If it's going.
we don't.
Did I draw for the plane or for the wind? Which one I did here?
You did for the. You did the plane, right?
Look at this. So here the jet is flying through the air that is blowing with the speed. Is blowing.
No, that's the wind. You drew the wind.
The wind is blowing. So the wind is blowing with the speed. So this part is of the wind. Can you see this part? I'm sorry. So this is about the wind. There's a wind blowing, So the wind is blowing in this direction. That means everywhere, if you see, there is a wind blowing like this. Can you see it? So the wind is blowing. I want you to draw like this. Somewhere on your whole thing. If this is the whole part, like the figure, it's like something like this. So the wind is blowing like this. Can you see? And you can feel that wind anywhere like this. So it goes this way. You see that wind is blowing in one direction only, and I'm trying to draw with the same kind of distance. There is a reason for me to make the same kind of distances from like this kind of thing. The arrows, I call them arrows with the point. It's a line segment, but with the arrow, it has a magnitude. Maybe going this is all. So the goal is just to understand that what is the meaning of a vector. Yesterday, remember, vector is something where they have the same direction. Okay, I did not draw properly. Okay, they have the same direction. So this is the 130 degrees, but what is the speed? 55 degrees. Okay, do you see that 55? So I'm making the same thing. Whatever the red color that I made here, this is the. Is that okay? So there is a dot here, and so this means okay. So this part is this. All this, there is a kind of a wind blowing in the direction northeast. Actually, right way to say northeast. But what angle? That's the angle. So all these are like, if I try to draw like this. If I try to draw this way, it means this is 30. Got it? So it's doing with the not. You don't have to do on the paper. So if I draw like this north side, those are the angle. Always making how much? How much is the angle making? Got it? So that's all I'm listing right now. So what I will do, I'll knock off this now, just to make it nice and clean. So for me, only this is important. Can you see that? So this is a vector. Now this is a vector. This thing represents the wind blowing at whatever that means, 50 miles, 55 miles. per second. Is that okay? Per hour, sorry, per hour. Now what we will do, the next one is, be careful. So where do I draw the other one? The jet has a speed of 765 miles per hour relative to the air. So where is the jet, which side is the jet going? On the other side, right? Agree? And it's like a big number. How big is the number? See, this is 55, right? And this is like almost 10 times or 12 times more. So the magnitude wise, I have to draw 10 times like that, you know. So, do you get what I'm saying? So this is like 55, and so now I'm talking about per hour, okay? So that means I have to do another one like this, which is saying, if it is 30 this side, I have to do 30 on the other side, agree? Because it says northwest, correct? So northwest, I mean, the jet is going this side. Okay. Did you get some idea here? So this is also 30 degrees, so let's put it 30 degrees. And then this is a point here. These are points very important. So what is we learned here? Oh my God, there are two vectors, Rebello. This one I want you to get an idea. What is vector means? A line segment. It has the start point. This is the start point. This is called. So now comes actual definition. So let's write that. As we are working on this, we now in the notebook, can you write down definition of a vector? What is a vector? So a vector is a line segment having magnitude or length or distance or quantity. I call it quantity or magnitude. Lot of words I use. And direction. Got it? So a vector is a line segment having quantity, that means it has a magnitude, and direction. That means now you can see this is in 1 hour, like this part is a vector, the one that is showing here. So this part, let's see in 1 hour, okay, this point which starts is called the initial point. So I want you to draw separately as like something like that. So it is a line segment. See, line segment basically means end points, you know. So line segment, but then the arrow, this arrow is very important, which direction is going. Can you see that thing? I can have line segment, this one also. See, this is also line segment. I can have line segment, something like this, see? This also is line segment. But the moment you put an arrow, that's where, this is what it shows me. It starts from here, and that's the end, terminal point. What is this point called? Terminal. So what did you learn so far? So far is, okay, vector is something like a line segment. It has a length. So this quantity means also length. Got it? Initial point, terminal point, and now because so that you can see it more clearly, I'll make it little bigger one. Okay, just for, and put a dot here. Let's call this point as P, and this point is called Q. Can you point? So I'm coming now to the definition. Okay, there is something. Now in this example, it's the wind blowing, maybe that's it. The other one is the jet going on the northwest side. Okay, so that's kind of our actual work. And this is like, okay, now we build up the vector. So now the question is, okay, this is the initial point. So that's the terminal point. How do we represent this? Now, from geometry we all know, in geometry, if this is a plane, any point, if there is a point, how do we represent this point quickly? Can you tell me? What do we call this? We just give uppercase letter, right? You remember? We just call this, hey, that's point A, correct? Yes or no? So that's the, so this is geometric representation of the, it's a symbolic way to write that's point A, that's point B, agree? But if I join up two letters S and T, what is this called?
Line segment.
Line segment. But how do we represent? That's my question. You forgot, right? See, on the geometry we were there. So you put S and T, you put there, and you just put a small. Can you see that? That thing means it is the line segment. Got it so far? You don't have to draw this because this is supposed to be known from beginning. I'm coming to here. That's important for us. But if I had to draw another one, maybe like this, and I call this as M and N. Can you tell me what is this called? And remember, this part is, I did not put a dot. Huh? See this, watch this. This is, did I put a dot here? There is no dot. What does that mean?
So
Is there a stop there? This is line segment, agree? This is called point, agree? Now from line segment I did something like this. What is that called? Somebody remember?
give us a hint, mister.
And I still remember in the geometry class I used to say, these are the things, you know, when I was in a small boy, little boy, that time my teacher was showing geometry and I started liking math because the way he was trying to show each of this, he was saying, okay, oh, and I liked the way he was trying to show, it made me sense, like, started liking geometry because of that, little things which are foundation. So, remember, everybody understand point, you just call point A, it's just a, when you take a pencil and make a dot, that's a point, that's a geometrical figure it is called. Now, why you call it point A, you cannot question the mathematician because they already said uppercase. They kept the lowercase for something else. And that's what I'm going to do quickly and then we go there. Starts with the R, ends with Y.
Right?
Yes, that's the ray.
Oh.
I know you knew it, but you were like, I wish. So ray is something where it has a start point and the other side has no end, it just goes on. Can you see that part? That's the difference between understanding the geometry, actual, all this thing. So ray is, or if you have a letter M and like this, so this kind of thing we put M, N like this. Correct? So almost the same thing is the ray and vector is like a confusion, but the ray is when it just goes on, got it? Make sense? And what is the line then? So when we put 2 points on the line, and I call this, let's say, W and Y, what is this called? How do we represent? No, remember this is represented by M to N, MN, and listen to me, there could be another point here, instead of N, can you give me another letter?
X.
Yeah, you can put X also. So it's the same as saying MX. Can you see MX? And it's the same thing. Can you see? So not necessarily it has to be M to N. It can be M to X also. Make sense? So ray is like non-stop, like, but it has the starting point. It doesn't have any point. It just goes on like that. So the second point could be anything. You could extend like this line like this, and make another point and call it maybe a Z. And say, so it is still written, it starts with M and Z. Do you see that? So the ray could be represented by so many of them. Did you get so far? And what is line? How do we write line? You just pick any 2 points, and here I put WY, but what do you write? You put WY and put up 2 lines. Can you see that? So this is called representation. So geometric representation is so important this way. And then angles, you know, anything angle, then we say, okay, you want to name the angle, you need to have a vertex, you have 2 rays, they begin from the same point, and then there is something, how far away are these 2 rays, and you can say, okay, that's, you take a point A, and then B, and then C, and so that's angle A, B, C, and that's another symbol is put up. So geometry is built up like this, got it? So where the hell this came from? Because that looks like that, that's it. And you want to know how much is this angle, maybe 30, 40 degrees? Let's see this one. They said, okay, let's put an M here, measure of angle. You get what I'm saying?
Yeah.
So that stupid thing is called measure of how much is the angle. But if you think, I'm just going quickly, if you think of like this, and I take 2 arcs like this. Let's take this point as D and this point as E. You know what is that called? I'm just going quickly on this because this vectors depends on this. So get an idea of, okay, this is the, what is this called? Got it? So there's a major arc, the bigger one, and the minor arc, and you say, okay, that arc is E, D, and you put text, correct? So a lot of things, everything I'm putting together now. Point, line segment, ray, line, and now comes arc, angle I should. So all these things like, oh, that represents the arc from there to the, and if you put, so what is the, then they ask you, what is the measure of angle? Like, you know, how much the arc measures? Well, all you do is how much the arc makes the angle at the center. So if this is 70 degrees, you say, oh, this arc measures 70 degrees, got it? See how representation? So this means how much the arc measures is just asking a question, what is the angle at the center? So the angle is 70 here. It could be 40, 60, 80. That's all that means. And then there's another thing called length of arc. So there is a difference. This is different. See? Now length basically means if you take this piece off and it becomes like this, correct? Do you see that? So this orange color now straight. Do you see? Straightened. So this is the length of the arc length. You see. So why I'm showing is that because the symbols used. Now the reason to show all this is now we go back here and say, hey, now how do we represent a vector? So it has a starting point and the ending point also. Not like a ray. Ray just goes like that. So this has a starting point and the ending point. So the mathematician said, okay, let's just write PQ. Okay, so initial point, terminal point, and then use the same thing. Can you see that? Almost like a ray. But this is not a ray, this is called vector. So this is vector. It is a, so basically vector is directed line segment. So I want you to write the directed line segment. So today our lesson is more of just understanding the concept, okay? Instead of doing 1,000 problems, let's get that. Okay, that's the, so P to Q. So P is the start point and Q is the terminal point. Got it so far, so good? But then they say, okay, now remember when we talk about it in the geometry, this is one way of calling line, but some mathematicians said, why don't you give a lowercase and call it as, that is P, small p, lowercase p. So this thing is called line WY, or it is called WY and put something like this, or you say line P. Do you get? Can I see your eyes watching this? So if there is a line, 3 different ways you can call. One is you can call line WY, correct? Because there are point WY. Another way to say is, you put WY and put on top small those 2. Can you see that? Or Another geometry teacher that time, mathematics, he said, hey, let's call it like a single letter. Just use why are you want to use 2 points? Just use single letter. So if you are using a single letter, you use a lowercase. Got it? So that's 9 small p. So over here the mathematician said, okay, this is a vector I know. This is where Valerie starts to walk. She walks northeast, and she walks maybe 5 meters, maybe 50 meters. So that's like 50 meters. Let's say she's walking this side, going this side. And then they said, okay, in that direction. So what I'm trying to say is this notation we use is, now this is mathematical notation. V starts with V. Can you see that vector? So let's call this as lowercase v. Got it? But we'll put a little kind of, can I write this? So that's the representation of the vector from P to Q. Got it? So what does this V be? So this is same as, did you get what I did? So far so good? Now, and then, so this is the representation of a vector, so which is same as PQ, let me write down. And then this gives the vector with direction, this is the direction, and there is something called magnitude. Now how big is this vector? And then I try to write 50 because 50 feet is what Valerie, let's say Valerie walks, and I can break this into 25 into 50, and then see I can break this into 22.5. What am I doing? Am I writing? No. How much? This if totally, how much is this distances? Correct, right? She walks 50 feet. So that means this is 25 feet, this is 12.5, and 25, 35, 37, you know what I'm doing, right? Kind of thing. So the goal here is just to understand magnitude. So the mathematician said, hey, how do we represent magnitude? So what they did is, let's put it 2 bars. So it's like an absolute value, just put a line, 2 lines, can you see that, 2 lines? And then whatever that thing you put vector here, this V, put V. And this is another way to write it, this one, P. So now what did we learn here is, that means is how much it is. So in this example, Valerie walked how much? 50, got it? Understood? All about how much magnitude. Maybe if you are driving, if you are walking in one side direction maybe, and in 1 minute you walk something, I don't know how much you walk, that's the meaning of that much. Did you get something about vector now? What is vector? So, what is a vector?
Like a directed line segment.
It's a directed line segment. It has a direction and it has magnitude, right? So how much is that? And so far so good, idea 100%. Now comes your grid. We'll do a lot of those kind of a little sketchy, like playing with these vectors. How do we add and subtract, this kind of thing. But if you understand this much, it's a lot of learning. So mostly we are going to in physics they have a lot of. Now see, there is a difference between see this part, weight, and let's see weight, temperature. What do you think? Is this a vector? Distance. Can you give me some of the things in the real life scenario? What are we always measure in life? One is the weight, right? You always want to say, I'm weight 140. What? Then you always check temperature. Oh my God, so hot. So we want to say distance. What is?
Height.
Height becomes distance, right? Anything else? Volume. Correct? How many ounces of, how much is this inside? How many ounces? This may be 12 ounces of soda we have, right? Pepsi, the small one. There is 8 also. But why is one? I'm just kidding. So my wife said, don't get a big one. Okay, get a small one. Did I make sense to you? in real life, okay, that's the weight. Weight is like pounds and the temperature, Fahrenheit, distance in miles, volume in ounces, fluid ounces. My question is, what are these called? Are they called vectors? It's just a number, right? Quantity. Does it have a direction? Does this have a direction? It's just quantity, right? But temperature also, oh, it's 72 outside. That's all you say, 72. Which side it is 72, you are not saying, right? Which direction is 72, we can't say. This is the distance, okay, travel. I mean, distance is just a distance. When I say distance could be, this also has a distance, see? This also is 8, let's say 8 inches, this also is 8 inches. Let's imagine they are the same. But doesn't say direction, right? So there is no direction for that thing. Volume also is okay, that's 8 ounce, 4 ounce. So just a fix. Is it this side or that side? No, nothing like that. But if I ask you, what about the speed? So you are driving, right? Suppose somebody asks, at what speed are you driving? And you can just see the speedometer and say, hey, can you slow down? It is almost 80 miles per hour. So that's like a kind of just a quantity. Can you see this? All these are like quantities. It doesn't matter which direction you are going. So these are called scalars. Can you write down this just to get an idea, understanding the difference between scalars is this, but vectors is different. Now vectors basically means mainly the velocity. Let's see what is that velocity means. So velocity. Now in science you learn what is velocity. Anybody can tell me quickly? Rate of change of displacement. Correct? It's like velocity is rate of change. It means you go with the distance maybe s2 minus s1 and the time taken is t. So that's all it's like how far have you gone? So s2 minus s1 is s2. So rate of change of displacement with respect to time. This t basically means t2 final time in the initial time. So that's kind of a thing. When we talk about velocity, it's always like which direction are you going? Like, okay? So this one doesn't have a direction, but when we talk about velocity, which direction are you moving? So that's called velocity here. Make sense? And when you have a velocity, and then there is also change in the as you move, you can go with the same velocity or in the same direction, but you can change the speed. You see, I'm just making something like this. What that basically means is, initially, watch this. Initially, you slowly, you start from here. Maybe I'm walking. Let's see, Valerie is walking. Starts slowly, then she covers every second. Like this is like 1 second she walks, then another second she walks higher, then she moves more higher. Can you see changing the? I know I'm a little deeper. Watch this. She starts walking. In 1 second you walk maybe 3 feet, but the next second maybe you walk 5 feet. The next second you walk maybe 8 feet. We don't know. So it's like you are walking, but then you are increasing. Can you see change in the velocity? It's like change in the speed, acceleration. What is that called? So acceleration. What is acceleration means? You are changing the speed. Changing what? Change of speed. And either when you accelerate, you go back like this, and when you de-accelerate, you go. You see the car, that happens all the time. So those are the physics things are called. What are they called? Vectors. Got it? Some idea, right? So vector is like, okay, those velocity, acceleration, and then I can pull this. See this? I can pull this in. So I can pull this whole. That's called you're putting a force. Can you see it? I'm forcing this. Or you push it. Push and pull is called what? Force. There's another guy. Now physics teachers are better to teach all this, but I like to show that okay, you pull When I'm pulling in some direction, right? Got it? So, hope that helps a little bit. And now, take your grid. Pull out your grid. My question, did you get some idea about what is vector means? And in real life also, oh, those are non-examples, these are examples. There is more also something called momentum. Did you hear this momentum? Mass into velocity? Into velocity. If you go on a bike and you hit something, there's not major damage, but just imagine your car is going and hitting, because the car has so much weight, so the momentum is going. There is a more damage done. So those kind of things are vectors. Just wanted to show it. Okay, now I don't want to do the grid there because there's a thing there. So on your paper, do you have a grid? Yeah. So make an x-axis. Quickly draw at the corner. Can you make just middle x-axis y?
Just in the middle part?
Yeah, middle is better. And we'll be coming back this later, okay? And how to figure out that. My question will be, why the hell we are learning all this, okay? So draw x-axis, y-axis. And if I ask you, draw a vector. So draw a vector. I want to draw, sketch a vector. I call this, and let's call it U also. So you can give lowercase and put an arrow and say, okay, sketch a vector from origin. So use the origin as this initial, and let's see. Start from origin, and then walk right 4 units and walk up 3 units. Bianca is smiling, why?
Because I love my mister.
Really? You started liking it?
I love it. I always liked it. So I'm taking this class.
Oh, okay. So I wanted you to sketch on your paper. Should we write 4 or should we? Okay, that is better. Let's take a simple example. I wanted to give something else. So here, let me go now. Since we already understood this, now comes the conclusion. Okay. So these are the point 1, 2, 3, 4. 1, 2, 3, 4. You already have a grid, so you guys are okay, right? I have to do this. Okay, so far. Now, I asked you to sketch a vector. Starting point is. Did you mark the point? Mark the point. Where is the other point? And you say, remember, this is so easy. What's the big deal about it? You already told us. You walk 1, 2, 3, 4, correct? Agree? And then you go up, right? So you go towards the west side. You walk west side to. So I said walk right, correct? So you walk right towards this is which side? Correct? Use. And then you go walk up. So it is 1, 2, 3. So this is the point. That's it. So simple. So this
line to this?
that arrow is very important. Can you see that point? That arrow. Now this point, there are two things. The representation of the point is 4, 3. We all know this, correct? See the fun? So that's the point. But if you want to represent this, there is another something called, because you walked, this is called horizontal component. Can you write down this? So these are like new words for you. You'll see what this is called, horizontal component. So horizontal component means how much you move to the right. That's all it means. And what is this basically means? Vertical component. Got it? So the coordinates, these are coordinates. What are these called? This point has coordinate, x coordinate and y coordinate, right? Yes or no? That's xy. So this point, but the whole red vector we write, now this is something new, watch this fun. This is the most, like, wow, what is this? So you just put a, you see that? That's called vector. So this is called component form. That means the moment you know this, component form means you should know horizontal component, like how much you went from this point, you make a triangle type of thing. Are you getting it? So this is the symbol. So if I call this vector as V, this is written as also. That's it. Got it? So if you know this point, and then if you want to know the magnitude of this, do you remember it's a Pythagorean? We can just put like this, put a square root. How much is this? And what is this one? So you already learned more than that. So here, so conclusion is what is vector, how to represent, and also how to write the component form. That's it for today. We will see tomorrow more on that, adding and subtracting. Tomorrow, you guys are not coming, really? Oh, did I?